Hello and welcome again. In the previous video, we discussed a little bit about this graph here, which is the divisions of cryptography in symmetric ciphers, asymmetric ciphers, and protocols, and we talked a little bit about what are one of each of those things. Now, a little bit further, the symmetric ciphers are basically divided into two categories. One of the block ciphers, and the other ones are the stream ciphers. Now, we're gonna talk about maybe the next couple of videos or more about the stream ciphers, and after that we'll concentrate on the block ciphers. So there are two kinds of symmetric ciphers, block and stream, and remember, symmetric means that the encryption and decryption key are exactly the same, so exactly the same key. Now, so what are the stream ciphers? So stream ciphers, remember, from what we were doing from the videos, the introduction to modern cryptography, we're gonna encrypt data, and data is gonna be represented in numbers, and in this case we'll represent that in binary. Now the stream ciphers, what they actually do is they encrypt bits individually, so one bit at a time. So what you do is whatever message or data you want to encrypt, you first convert it into a binary, and so the stream cipher will encrypt it bit by bit, not bytes, but bit by bit. So individual bits means zeros and ones. So basically what the stream cipher is going to do is something like this. So this is the picture. So I have here the stream cipher, which we'll discuss a little bit of the inner workings in general inner workings of the stream cipher later. But basically what this picture means is this. You have some box here that's going to do the encryption, which is basically is going to take one bit. This is what this notation here means. This /1 means it's going to take one bit and it's going to spill out one bit. So you take one bit of plain text and you're going to output one bit of ciphertext. So this is what the picture means here. So one bit at a time, and the stream cipher is something that it doesn't something there, but we'll discuss that in a second. So as I mentioned earlier, what you have to do is something like this. So you take a plain text in binary, whatever that might be. So in this case, what I have here is a byte. So I have 8 bits of information, zeros and ones. And this stream cipher is going to process bit by bit in the following way. So for example, this is just an example. So let's say I'm going to take the first bit. So you're going to feed it the first one from right to left. That's why it's called stream, because this flows through the cipher and it comes out here. So what you're going to do is, for example, here, I'm going to take the first bit, which is that one over there, this one, and it's going to go through the stream cipher. The stream cipher, of course, is going to do something to it. It's going to either keep it the same, so keep it at 1, or transform it into a 0, so the other bit. So for example, let's say it's transformed to 0. Let's me write down here with a yellow 0. Then I go to the second bit, and the stream cipher is going to do the same. So imagine that this one, the first one, already went through the stream cipher. So I'm going to erase it, and it's not there anymore. Now it's going to take the second bit, counting from right to left. It's going to go through the cipher, so there's 0. The stream cipher will either keep it a 0 or change it into a 1. Let's say, for example, in this case, I'm going to change it into a 1. And you keep doing that. Okay, you keep doing that until you go through the whole collection of zeros and ones here, bits, and then you fill out this part over here. So the answer here should be a 8-bit or a byte. So something like, it could be something like this: 0, 1, 0, 0, 0, 1. So I have there now 8 bits. So if this is the process, then let's imagine that is nothing here anymore, and all the bits already went through the stream cipher. So that's basically what the stream cipher is. I mean, in very general terms, a process bit by bit. You take the plain text and binary, read that from, if you wish, from right to left, feeds it into the stream cipher, and it streams out the ciphertext. That's basically the idea of the stream cipher. Of course, the inner workings of this is a little bit more complicated than I just told you. This has to be something going on here that transforms the bits individually. Now, the block ciphers, on the other hand, you see the stream ciphers, they process bit by bit. The block ciphers are going to process blocks of bits at a time. So what do I mean by that? So let's think about it in this way. So you take plain text in binary again, and the first thing you do before you feed it into the block cipher is you divide this into blocks of bits. So this notation here means that this particular block cipher is going to have a block of 2. So it's going to transform 2 bits at a time. That's why it's called a block cipher. It takes blocks of bits and transform it. So it takes a plain text and blocks of 2 bits in this particular case, and then it comes out here as a block of 2 bits and it goes right there. So what you have to do really at the beginning is just you have to divide it first into the block, whatever that block might be. So let me use another color here. So let's say you take that and you divide it into chunks of 2 bits. And so every 2 bits here will go through this block cipher. The block cipher will encrypt it. It's 2 bits at a time, and it's going to come out here as 2 bits. So for example, if I have the 1 0, let's say I'm going to transform it into, let's say, 1 1. And you do that process until you end up with all the plain text here, all the bits in the plain text. So of course, this is going to be a block of 2. Now, modern ciphers, of course, they don't work on blocks of 2 bits. The blocks are a little bit larger. Now, one problem that we might discuss later is what happens if you see here, this is a plain text. It's okay to divide this in blocks of 2. And so I have complete blocks. But let's say my cipher is blocks of 3 bits. Now, I have 8 bits here. I cannot divide it in blocks of 3 and have a complete block. So when that happens, when you plain text, you cannot divide it exactly into the number of blocks that the cipher requires. There is a process called padding, and that's what we're going to do maybe later, but a lot later in the class. So that's the idea. So the idea is you're going to have blocks. How do you get these blocks later? And if there's the length of this plain text is not divisible by the length of the block, then you have to do something about it. You have to do a padding. Now, in general, what happens is when you have a block cipher, of course, the block is going to be some number of bits. And so it's going to take blocks of B bits at a time, and the block cipher will encrypt B bits of that, whatever that plain text is in binary, and will spill out the ciphertext going through this like this. So that's why it's called a block cipher. Now, again, what you have to do is you have to do plain text over here, and you're going to divide it into chunk of B bits. If it's not multiple, then we do something about it. So the block here is a B bit. So some of the modern ciphers will use blocks of 120 bits and so on and so forth. So bigger blocks for the division of the plain text. Now, these are the 2 main ciphers, symmetric ciphers, which means that for the block cipher here, for this block cipher, and for the stream cipher, the key for encryption, decryption is going to be exactly the same. Now, the block ciphers are most commonly used on the internet. That doesn't mean that there are no stream ciphers on the internet. There are some stream ciphers. And stream ciphers are most commonly used on devices with small resources, like, for example, cell phones. Remember that I talked about the cell phone network, that the cell phone, your voice is going to be encrypted, and that process is done by a stream cipher. So basically what it happens is your voice is going to be translated into a string of zeros and ones into bits, and there's going to be a stream cipher processing a bit at a time before it's sent to the cell phone tower. Now, the stream ciphers, they actually work. the process, one of the processes that is very simple, and the process is the bitwise XOR or exclusive OR operator, which is a bitwise operator. So they're gonna use this operation, the bitwise exclusive OR. So let's just remember what the table of the exclusive OR here is before we move on into how more or less this stream cipher is gonna work. So let's fill out this table here. So I have the values of the bits here. So X will represent 1 bit, Y will represent 1 bit, and these are all possible combinations of zeros and ones that I can have for 2 pairs. So they could be both 0, 0, 0, 1, 1, 0, 1, 1. There are no more possibilities for X and Y for those pairs. So 4 possibilities. And of course, X and Y will represent bits here. So to fill out the table, what you do is X sorg X is 0. Let me use the color here. 0. 0 for the next one. This one, 0, 1 is 1. I use the color 1. Then 1, 0 is 1. And 1, 1 is going to be 0. Okay. That's the XOR operation. And for this class, at some times, I'm going to use this notation here, this the circle that you see there. Instead of using the XOR there, we're going to use this symbol here, this one. I use the color yellow there, that symbol over there. It's like a plus sign with a circle around it. So that will be the symbol for the exclusive OR. Now, how you can memorize this table without having actually to look at it? One way to do it is like this. Imagine that this 0 represents even number and 1 represents an odd number. And this XOR will be addition. So when you have an even number, 0 plus an even number, you have even. When you have even number plus an odd number, you get an odd number, right? So you take 2, for example, is even. 1 is odd. 2 plus 1 is 3. That's odd. Odd number plus an even number. So it's again an odd number. Imagine this is an odd number, for example, 3. And an even number, for example, 2. Then you get 5, which is an odd number. And if you add 2 odd numbers, which is a representation of 1 here, you can think about it that way. This is odd and this is odd. When you add 2 odd numbers, you get an even number. So you have, for example, 5, and you add 3. 5 and 3 are odd, but 5 plus 3 is 8, which is an even number. You can memorize it that way. It doesn't matter really how you memorize it, as long as you know what this means here. So 0, 0, this symbol 0 is 0, and so on and so forth. All right, so that's a little bit of review there. So how is the encryption process in the stream cipher? So I'm oversimplifying here again. Before we start to look at how the encryption process is, remember that the stream cipher is going to process a bit at a time. So we're going to take a bit here, X, Y, and S are bits in this case. X is the plain text which will go through the stream cipher, and this is the operation that's going to be done here. And something is going to be fed into that stream cipher here to make that operation. That is another bit. So this I have a plain text here, as X is the plain text, and this comes out here as the ciphertext. So you take here is the X, the plain text, you feed it into the stream cipher, and you have another bit. That this bit comes from the key. How is this bit coming from the key? We'll have to have a discussion about that. It's a little bit lengthy actually. This bit here is not actually the representation in binary of the key. It is something else. But for the moment, just believe me that there is a way to get a bit from the key without looking at the representation, or basically not actual representation of the key in binary. So you have an X, a bit, an S, and that's another bit. It's going to go into here, and of course what comes out is X or S. And so in Y here I will be representing the ciphertext. So 1 bit of plain text is transformed into 1 bit of ciphertext with something that comes in here that comes from the key that we are using to encryption. So let's see a particular example. So for example, let's say Alice wants to encrypt the letter A and send it to Bob. So the same situation we had before. One way we can do this, and this is not the only way we can do this, is we want to look at the representation of the letter A in binary. So to do that, we can use the Ascii code. So you represent the letter A in binary using the Ascii code. Now, if you don't know what that means, remember I went over a little bit, just very briefly, in the previous video about what the Ascii code is. Basically, what it is you have all the symbols in the English-speaking language, and then you're gonna assign to every single one number, whether that be in decimal form or binary form or hexadecimal form. It doesn't matter here. So what we want to look at is the code that represents the letter A, which is 65. So A is represented by the number 65 in the Ascii code. And what we're going to do is, remember, because the ciphers now are going to work on numbers, and this one specifically is going to work in binary, we want to represent the number 65 in binary. Now, the 65 in binary will have this representation. This 2 that is over here means that I'm representing the number 65 in binary. And if you count this here, it's going to be 7 bits. That's what the Ascii code is doing. So it has the 7-bit representation for the letters. If you count here, this is 1, 2, 3, 4, 5, 6, 7 bits. 7 bits of information. When you want to encrypt a cipher, plain text, which is this one, representing the letter A, and you feed it into the stream cipher, what you have to put in here is the same number of bits that are in the plain text. So for example, in this case, here I have the plain text, and I'll have to fit into the stream cipher 7 bits that are coming from the key. Okay, so for example, if I have 20 bits here that come into the stream cipher, I will have to feed into the stream cipher 20 bits that are coming from the key. And this process here, or how to get these bits from the key, is actually a very important process. That's the main part of the stream cipher, and we're going to talk about that later. So for the moment, just believe me that there is a standard process, or not very standard. So some of the implementation of stream ciphers will tell us how to do this choice here of bits coming from the key. Same number here of bits as the number of bits in the plain text. So I have to make some examples. So let's say, for example, here I have the following situation. I have a plain text here that represents this plain text. This is binary representation of the letter A. And so for the stream cipher, I will need 7 bits that are coming from the key. If you count these bits here, there's going to be exactly 7 bits. So I'm going to process bit by bit here. So let's say, for example, and I'm going to cross out with yellow the ones that I'm doing. So I'm going to process bit by bit. So for example, this one here will go, and this one here will go through the stream cipher. So it's going to be 1, so 0, that's a 1. And then go into the next one. So it's 0 and 0. 0 and 0 is a 1, is a 0. Then 0 and 1 by SOR is a 1. And then you have 0. And then the next one will be 1. That's going to be a 1 because it's 0. This 0 that you have here, SOR this 1, that's going to be a 1. And so let's continue like that. So 0 and 0 is going to be 0. And then you have 0 and 1 is going to be a 1. And finally, you have a 1 and a 1, and you have a 0. So as you can see here, this I have again 7 bits. So I took a plain text with 7 bits. I feed into the stream cipher 7 bits that are coming from the key, which we'll discuss how we get the 7 bits later. And then I'll put here the ciphertext, which is again 7 bits over here. So remember, this was the letter A. This was coming from the key. So this is the key that Alice and Bob share. But remember, there's 7 bits that not come from the key, but are not the representation in binary of the key. There's something different going on in here. For the moment, just take my word for it that you can do that. And And then so you get here the ciphertext. And this is the part that Alice will send through the insecure channel. So this part here, this bits, okay, this bit. So what she will send to the insecure channel. So let's look at the situation now. So let me choose the white color here. So you have Alice here, and so we have here the cipher. So she took the letter A. Before doing that, of course, she represented that as a binary. Go to the stream cipher. The stream cipher spill out this binary that I'm going to show here with the arrow, this one. This is the one that's going to go through the insecure channel. So let's say here to the insecure channel, and it go through Bob. Okay. Now, if you want to look at what that is, what number that is, 0, let me write it down over here. So 0, 1, 0, 1, 1, 0, 1. You need to know, if you want to know what the letter, it doesn't matter really what the letter is here, but just to look at what this is. So remember, to represent this binary number in decimal, these zeros and ones are denoting the coefficients of powers of 2 that you have to put in the number. So I'm gonna start here just to review how that is done. So you start with 1 there, and 1 will be the coefficient of 2 to the 0. So it's gonna be 1 times 2 to the 0. I hope I have a space there to do it. The next one will be the coefficient of 2 to the first power. So it's gonna be plus 0 times 2 to the first power. I'm not gonna have space there, so I'm gonna do it over here below. So let me start again. So yeah, so 1, the first one that you see there is going to be the coefficient of 2 to the 0. The second 0 is going to be the coefficient of 2 to the first. This third one that is here is the coefficient of plus the coefficient of 2 squared. This one here, the fourth, is the coefficient of 2 cubed. And this guy here, so plus 0 times 2 to the fourth. Next one, plus 1 times 2 to the fifth. And finally, a plus the last 0 times 2 to the sixth. And then whatever that number is, that's going to be your decimal representation. Okay, so the zeros there, of course, don't matter there for the representation. So if you cross out the ones that are going to go to 0, so this is going to go to 0. This one goes to 0. This one goes to 0. Okay, so basically what you're going to have is this guy here, 2 to the fifth, 2 cubed, 2 squared, and 1. So you're going to have 2 to the fifth plus 2 cubed plus 2 squared plus 1. And if you work that out, that's going to give you 45. Okay, so just do the operation there. It's going to give you 45. So that 45 is basically the number that goes to the insecure channels. If you don't want to look at it as the binary, so the 45 will go to here. Now, if someone is looking at this here, which is always the case because Eve is always listening. Eve is there. Eve is there. She's going to see this number. Or basically, what she's going to see is that this is the ASCII representation of something. And if you look up the table for the ASCII of 45, that's the hyphen of the minus sign. So this guy here, the 45 in ASCII is the hyphen. So this the minus sign, the hyphen of you can call it hyphen of minus sign. So if Eve is looking at this, what she will see is the hyphen going through that insecure channel. And of course, Bob will also get the hyphen. Okay. So what happens here is, okay, Bob now has to decrypt that message, well, which is a small message, right? So it's only 7 bits. And so it has to decrypt it. How is that process of decryption? Now, all that I did here was the process of encryption. Have a plain text, express it in binary, put it through the stream cipher using some kind of here of sequence of bits that are coming from the key. Again, repeat again, they are not the representation of in binary of the key. They come from the key, but not from the binary representation exactly. Yeah, they come from the key, but not the representation of the binary of the key. And then, of course, you put it here, and then it goes through the encrypted message goes to the insecure channel, and even Bob will get this part here. And of course, Bob will have to know the key, or basically the stream of characters or the stream of bits that it was generated here to decrypt the message. So Bob will know what this is. This is the thing that comes from the key. And because he received 7 bits here, he knows he received 7 bits, though he knows that he has to get 7 bits from the key to get the decryption, and the 7 bits he will get is exactly the same as the ones that are in here. So I'll explain that, how do you go to the process of decryption in the next video.